Booyah! This table gives selected values of a continuous function, which is important information for us. And this is actually the most important information for us. And an increasing function that is called h. This is the h function. So we're given x values and h values for those x values. It says we're interested in the area under the curve between 4 and 9. That's what they gave us, 4 and 9. There's your interval. And we're considering using left and right Riemann sums, each with 5 equal subdivisions. Usually it's equal. I mean, you can also do unequal, but anyways, we won't go there. Order the areas from least to greatest. Okay, so we need least on top, least, well, I know how to spell, and then greatest. All right, so we have to have a least and then something in the middle and then greatest. Which one goes on top? Which one is the least? Which one is the greatest? Which one goes on bottom? And so I kind of want to take a shortcut. I hope you guys don't mind. I don't really want to graph all these points because it might take a little bit. I'm here to tell you guys this piece of information right here, increasing. It's increasing, which means we already have an idea of what this graph might look like. Okay, now there's a couple different ways the curve can look when the graph is increasing. Okay, this is increasing. This is increasing. This is increasing. They're all increasing. Okay, because if you were to pick a point right here and then pick another point to the right, you see it goes up. It increases. And that's the same for each of these. Okay, no matter which one you pick. All right. So the question is, which one's going to be the least? Because we know that the actual is always going to be in the middle. Actual. Between the left and the right, it's usually always. I mean, I'm sure you can think of one situation where actual might be the least or the greatest, but most of the time it's not going to be like that. So which one's going to be the least? The left or the right? And so I want to look at one of these. Let's see. Let's look at this guy right here. Let's draw the left side rectangle. So that means I'm going to use the left dot to draw my rectangle. So would that give you a least, like an underestimate or an overestimate? Let's see, let's draw the next one. The next one, let's see right here. Nope, that's wrong. There we go. Okay, would that be an over or underestimate? Under, because it's not including this little space right here. That's a left side Riemann sum. And what if we do the opposite? What if instead we start with this guy and we go and we draw our rectangle? And then we have another point right here. Okay, is this going to be an over or an underestimate? It's an over because we have our rectangle sticking above our curve. And so we have an overestimate. Okay, and that actually is true for all of these. All right, so if I draw this rectangle right here, you can see we're missing area right there. If I draw this left side rectangle right here, again, we're missing area right there. So your left side is going to be your least estimate. So we're going to put left right here. We'll say left, left. And this is the right. The right will be the overestimate. The left will be the underestimate. And that's how you do.